Hi, Kevin. What does EDM Intelligent Solutions do?
Hi, Mark. EDM Intelligent Solutions has been providing ultra-precision manufacturing services, 3D industrial metrology systems, and 3D metrology services to customers in the aerospace, automotive, communications, defense, medical, and scientific industries for the last 25 years.
What type of manufacturing services does EDMIS provide?
So EDMIS offers CNC electrical discharge machining services, including wire EDM, sinker EDM, EDM hole drilling, and laser ablation, along with micromilling and precision grinding.
How does EDMIS inspect the parts that they manufacture?
So we have an entire line of business dedicated to 3D metrology systems and services. So our manufacturing team has the advantage of in-house metrology experts ready to assist with measurement and verification of manufactured parts. We work to include 3D metrology in the manufacturing plan for every component that we make for our customers.
What is 3D metrology?
So the quick definition of 3D metrology is the scientific study of any physical measurements. In relation to the industries that we work in, it encompasses the precision measurement of the tools, fixtures, and machine components using data acquired on the surfaces of those components in the three axes, X, Y, and Z.
Tell me more about your 3D metrology equipment.
We have two 3D metrology platform types, CNC-based and robotics-based. Both have their advantages, with the CNC-based system being the most unique and different from what is typically seen in the market. Our MVI5 3D metrology center is comprised of a robust 5-axis motion system with a FANUC CNC control that creates a rock-solid platform for our different types of 3D sensors. Our RSH robotic metrology systems use industrial 6-axis robot arms carrying 3D metrology sensors in place of typical robot end-of-arm tooling. This robot unit is located in front of a high-precision rotary 7th axis to create a system that allows us to move both the part being scanned and the sensor nearly any direction to give the sensors the best optimized view of the part. Both systems are capable of capturing and measuring features with micron-level tolerances.
What type of measurements can be taken with your 3D metrology equipment?
We are able to match nearly all point-to-point measurements that are taken with traditional inspection methods. These would fall under what we call form measurement, dimensions like lengths, step heights, ID, OD, radii, angles, and etc. Since we are capturing entire surfaces of the part being scanned and creating large point clouds of data, we can also easily overlay that point cloud on top of the nominal 3D CAD model of a part. This allows us to complete difference measurements that quickly show any deviation of the actual part from the nominal model. This type of measurement has a huge advantage over single point-to-point form measurements because you are essentially checking every feature of the part at the same time. And it is displayed in a very easy to understand graphical user interface using a color map. Green areas of the scan are in tolerance, red areas are not. A unique capability of our systems is non-contact surface roughness measurement. The traditional method of using a tactile profilometer is somewhat limited to being used on flat surfaces and simple shapes. Using our optical 3D sensors, we can capture the surface data on any intricate shape, digitally remove that shape, and then measure the surface roughness, either in the traditional profile sense, which results in an RA value, or in the modern surface method, which results in an SA value. We are seeing more and more customers request both of these methods, since the RA is a great way to translate our measurement back to legacy designs, and SA gives a better representation of the surface roughness of the entire surface of the part.
So how does an end user utilize these 3D measurements taken with your equipment?
The traditional use of filtering between parts that do and don't meet tolerance makes up a large portion of the applications we see our systems and services being used in. Where the advantage the equipment affords our end users really shines is when it is used to improve a manufacturing process. Using the measurements from part to part to feedback to the manufacturing process, adjust the machining parameters, and bring the next parts closer to nominal design values not only reduces the scrap rates, but eventually reduces the amount of inspection required to verify the process is outputting good parts. The data gathered using our equipment instantly gives the manufacturing teams direct insight with quantified evidence of how their process changes are resulting in less of the part tolerance being used. This allows for a greater SBC interval, which increases throughput and reduces overall cost of the product being manufactured.
How easy is it to use the 3D metrology equipment?
So ease of use is a major feature built into our equipment. Starting at the programming level, we optimize the process of creating an inspection program by using the nominal 3D CAD model as a guide for the machine motion. Our EDMISI programming interface reads in that 3D CAD model and then suggests to the user an optimized and collision-avoidant motion path that is best suited to capture the measurements of the part. The user simply selects the areas of the part they want to measure, and an inspection program is generated. Our onboard collision avoidance software automatically runs the new program in a virtual version of the metrology equipment and verifies that no collisions are detected between the part and the system. Loading the part into the system and running the program is a simple task through the use of standardized work holding and our EDMIS program management system. Once a part is loaded, the end user simply types in the part number and the system automatically searches its database for matching programs. Programs can also be called up by scanning a barcode on the manufacturing operations routing sheet. Once the inspection program has been run and the 3D data captured, the specific measurements required to inspect the part are automatically processed and output to the end user in a number of ways. List of form measurements can be saved as PDF reports or transferred automatically to quality department databases. 3D difference measurements can be shown instantly on the screen, alerting the end user to areas of the part that are out of tolerance. And surface roughness measurements can be output in both RA and SA values to fully characterize the surface finish of the part being inspected.
Okay, so how much training is needed to effectively use this type of 3D metrology systems?
So that's a really good question. Our applications team normally works with end users for a few days to train them on the programming and operation of the systems. If the end users are proficient in any type of modern 3D CAD/CAM system, they're able to pick up the EDMIS interface very quickly. Programming of the actual measurements of the 3D data is very close to the same process used to snap dimensions in a CAD/CAM environment.
Okay, can you tell us an exciting application of this metrology equipment that you can share with us?
So our work with a major aerospace OEM utilizing this equipment to measure critical flight components that featured unique organic surfaces is very exciting. Our 3D scanning equipment is being used to characterize the variations in the surface of the entire component, which was not possible before using traditional metrology equipment. This new insight into each component allows the customer's engineering team to fully understand how slight differences during the manufacturing process of each part affect the overall performance of the component. So much so that the customer has begun to be able to predict the performance of a machine component based upon the 3D scans and measurements provided by our 3D metrology systems, without having to subject each finished component to traditional functional testing, which is extremely costly.
Okay, if someone's interested in learning more about how these types of 3D metrology systems and measurements can be applied to their manufacturing application, what's the best way to start the process?
So I'd recommend that they contact our applications team here at EDM Intelligent Solutions. We'd review their part design and quality requirements, and oftentimes complete sample 3D data captures and measurements on one of their parts using our 3D metrology systems so that they can see real data off of their own part. After that, we'd work with them to determine which of the two options we offer, on-demand 3D metrology services or a 3D metrology system installed at their facility, would best suit their needs.
Okay, these 3D metrology systems definitely offer new capabilities in terms of quality control and process improvement. Thanks for giving us a walkthrough of what the 3D metrology services and systems from EDM Intelligent Solutions are and how they can be used by manufacturing and quality professionals to create better products and increase quality and optimize throughput.
Thank you, Mark. We appreciate the opportunity to share this information with classes such as yours that are related to the theories and practices of quality within manufacturing. Technology is advancing at an amazing pace, and communicating these developments is key to help them reach the markets, companies, and teams of professionals that can take advantage of them the most.